Mathematics is a science of perfection. This science requires 100% accuracy in defining objects, or anything that we talk about, it has to be defined 100%. There should not be any kind of ambiguity in our definitions. That is why mathematics has developed its own language, which is accurate 100% on the target. So this language starts with the concept of set. Now set is a very simple concept. Whenever there are many objects and we refer to them, for example, set of all human beings on the earth is a object. Set, it's a collection of objects. Collection of objects is called a set. The only thing is, this collection should be well defined, in the sense that who is included in the set and who is excluded in the set should be very, very clear to you. So let us modify our definition of sets. A well-defined collection of objects is called sets. So I'll write it for you. Definition. A well-defined collection of objects is called set. A set. What do I mean by well-defined? For example, if I say set of all the peoples in the world who have a sense of humor, how do I know whether the person has a sense of humor or not? And how do I calculate the sense of humor? It's not possible for me to define or exactly find out a person who is definitely have a sense of humor and those persons who are not having the sense of humor. So this is a very vague and ambiguous definition. So this is not well defined. But if I say set of human beings on the earth, then it is very clear what I'm talking about. If I say set of vowels in the set of alphabets, if I talk about all the characters in the alphabet, it's a well-defined set because I know exactly what is included and what is not included. So that condition on which you can decide whether the object is inside the set or outside the set, that condition has to be laid down properly, right? If that is done, then it is called well-defined set. For example, suppose I say set of living creatures on the Mars. A set of living creatures on the Mars. How do I know? We have not even visited Mars. Nobody has actually seen the surface of Mars except some rockets which have gone, some Chandrayaan type rockets have gone there. But they have not found out anything. But doesn't mean there are no creatures, right? Living creatures on the Mars, we do not know. So this kind of set, although it is stated here, has no meaning because it is not well defined, right? But if I say set of numbers from 1 to 100. Now, set of numbers from 1 to 100, actually, this is also not well defined because numbers, which kind of numbers? There are types of numbers. So set of, I should say, natural numbers. Natural numbers. Set of natural numbers from 1 to 100 is well defined. For example, half is not included here. 1/3 is not included here. Why? Because half and 1/3 are not natural numbers. So this criteria defines exactly what should be included and what should not be included. So that is why the word well defined, very important. So wherever you talk about a set, the collection of objects is called a set, provided it is well defined. Now all those objects which are inside the set are called elements. They are called elements. All the objects inside the set are called elements. Okay. So element, for example, in this set, 2 is an element, 3 is an element, 4 is an element, 1000 is not an element because it doesn't belong to the set. Correct? So that is how we define a set. Okay. Now, next, we are dealing with how do we represent a set. right? How do we represent a set? So representation of sets. So one thing is very clear here, that all the sets are denoted by capital letters. Sets are denoted by capital letters, such as A, B, C, D, etc. Okay? And the elements are denoted by small letters. Now, for example, A, B, C, these small letters generally denote elements. And when I say that this is an element from this set, that means this element belongs to this set. For that, we are using another symbol, and that is called, actually it's called epsilon in Greek alphabet, so it is of this type, epsilon. So when I say A is a member of capital A, so I would say A belongs to capital A. And if I say that A does not belong to capital A, then I have to just say B does not. So does not means just cross this like this. Does not belong to capital A. So here is a symbol which indicates A is a member of A, or A is an element of A, and B is not a member of A, right? So A belongs to, this is read as A belongs to capital A. Okay, that means A is one of the elements in the set, and B does not belong to capital A means B is not a member of the set A. Correct? So, for example, let us see. Now, generally sets are denoted by two methods. One is called roster method, or let us call it, a better name for that is list method based. List method. Now, what do you mean by list method? Whatever it means. List means what? A list, right? So you just make a list of all the elements included. For example, I'll use a curly bracket and I'll write here A, B, C and D. Correct? So this set is enclosed in a two curly brackets, and then A, B, C, D are the elements in it. And if I want to refer to this, all the collection as a set, I will call it capital A. So capital A is A, B, C, D. This is called list method. That means you are just enumerating, actually writing the symbols representing that particular element. For example, if I want to indicate a set of students in, say, division A, so I will take the names of all the students and I'll write their names one by one. If there are 100 names, I will have to write 100 names here and contain them into curly bracket. That is called list method. Okay. But there is another method. For example, suppose A, B is equal to 1, 2. Correct? So this is the set. So here we can say that A belongs to capital A, right? C belongs to capital A, but E does not belong to capital A. Correct? A is a member of A, B is a member, C is a member, and D is a member, but E is not a member. Whereas B is a set consisting of only two elements, 1 and 2, right? So this kind of writing a set by just enumerating or actually mentioning all the names of the objects, that is called list method. But as you can see that there are many sets for which this is not very convenient. So for example, if I want to talk about set of birds in the world, I cannot go on writing the names of birds. I do not know how many of them are there. But the set is well defined, right? And how many objects it has, nobody knows, right? So in that case, the list method is totally inadequate. Okay. So there is another method. That method is called rule method. rule method. Now, what is rule method? That means you lay down a rule. You lay down a criteria. You lay down certain condition, which if satisfied by the object, it is a member. If it is not satisfied by the object, it is not a member, right? So a condition is set up, a condition is laid down, a criteria is laid down, and then we say that if the criteria is satisfied, then you are the member, otherwise you are not a member. In which case, I don't have to specify the names on the list of objects completely. For example, suppose I define a set A. Now how it is done? You write a curly bracket. Then every element will be denoted by some letters like X, Y, Z. So here I am using X. And I'll call it like this. Set of. So this set, if I want to write or pronounce it, I'll say set of all XS. XS means the elements type of X, right? Set of all XS, and I'll write such that. I will say such that. Now this such that is indicated by a straight line here. So when I write curly bracket X and this straight line, whenever you see this, you have to read it like this. Set of all X's such that, right? As I was saying, a set A, this curly bracket means set of all X. This X means X's, right? Set of all X such that, that straight line indicates such that X square is equal to 1. That means all those numbers whose square is 1, right? So that is a criteria, that's a rule. For example, if I write 2, so 2 square, is it equal to 1? Answer is no. So 2 does not belong to A. 2 does not belong to A. Whereas minus 1 belongs to A. Why? Because square of minus 1 is 1. And in fact, there are only 2 numbers whose square is 1. After all, there are minus 1 and 1. So if this set is to be denoted by a least method or indicated by least method, it can be written just as minus 1, 1. So this is the least and this is the rule. So you can clearly understand the difference between the two. This method is much more useful whenever the number of elements are relatively difficult to find out. So it is better to find out by use this. There are 2 ways of writing the set. Okay. Thank you. Then so there are problems of this type, that you are given a rule method, a set is described by your rule method, and you have to find the set in the list form. For example, let us see, very simple example. So it will be like, I'm sorry, this root. So for example, if I say, let us take a set A such that set of all x's or numbers x belong such that x square minus say 3x plus 2 is equal to 0. This is the example, right? So this is a criteria. Square of that number minus 3 times that number plus 2 ought to be 0. अगर ऐसा number है तो वो इसमें included है, नहीं तो नहीं है. In other words, I want to find out the least method, how many elements are there and which are exactly them. For that, you all know we will have to solve this quadratic equation, right? So this quadratic equation, if I want to solve, how do I do it? X square minus 3x plus 2 equal to 0. What does that mean? I'm going to write it like this. X square minus 2x minus x plus 2 is equal to 0. So I'll have to split this minus 3 by using 2. So 2 into 1. So minus 2 minus 1. Then I'll take out x common from both. Then it is x minus 2 and minus 1 common. X minus 2 equal to 0. Now x minus 2 itself is common. And then the other factor is x minus 1 is 0. You all know that when 2 numbers are giving 0 as an answer, either one of them is 0 or both are zeros. That means x minus 2 is 0 or x minus 1 is 0. So x is equal to either 2 or what? 1. Correct? So the same set you can write in a least form in this manner. Roster format is it called. It is called roster form. So there are 2 elements in it, 2 and 1. Right? So these are the two representation of the sets, right? Now, what I mean by set is this, but then there are, let us define about types of sets, right? So let us talk about types of sets. Now, the most important sets in the world of sets is the universal set. Universal set means what? It contains all possible objects of the similar type. For example, if I am talking about the all the civilians staying in Bombay, all the members or all the civilians staying in Bombay. What could be the universal set? So the context makes it very clear that I am talking about all Indians, right? So in this case, all Indians will be universal set, and the set of Indians staying in Bombay will be a part of it, right? So from the context, it is very clear. If I want to talk about set of parrots, what is the universal set? Universal set is set of birds, right? If I want to talk about monkeys, what is this? Chimpanzees. What is the set of? What is the universal set here? Set of monkeys, right? So types of sets. The first set is called universal set. The largest among them, universal set. It is either denoted by, there are two symbols generally used. One is U and other is X. So I may use U sometimes, I may use X sometimes. But what is universal set? Set of all possible objects. Set of all possible objects. Set of all possible objects is called universal set. Now you will be wondering, what do I mean by set of all possible? The all possible is always indicated by the context. For example, if I am talking about set of textbooks, what is the universal set? Set of all the books, right? So it is very clear what is universal set. Okay. Opposite, exactly opposite of universal set is empty set. Empty set. A set without any object. It's called empty set, denoted by this symbol, and it is pronounced as phi. It's a Greek character for the letter F, right? Greek equivalent of F, right? Phi. Or we may just write a bracket which is empty, right? So most of the times we'll be using this. Now, what is the necessity of defining such a set? Because you can always define a criteria which is impossible to be satisfied by any character. For example, set of all human beings with wings. Now, there are no human beings with wings. Therefore, there is no such character in the world. There is no such object in the world. Therefore, this set will be empty set, right? So, there are two sets fundamentally different. This contains all elements and this contains no elements at all, right? Now, before going to the next concept, let me have a visual representation of sets. How do I represent sets in a visual form? In order to represent sets in a visual form, there was a mathematician whose name was Venn. And the procedure is always referred to him as Venn diagrams. Venn diagrams, in order to immortalize his name, because he introduced this method. So what he used to do is to draw figures. For example, universal set. If I want to indicate universal set, then I must draw a huge rectangle as large as possible. Now, any other set is a part of this set. So, whatever set I am talking about, for example, suppose this is set of birds. Universal set is what? Set of all birds in the world. Okay. Now, if I take set of parrots, it will be a part of it. Parrots. Correct? Then, if I talk about, say, sparrows, like that. So, all the sets of separate sets of birds will be part of this. This is a universal set and this is a part of it. So that is called universal set. Universal set, it has always been indicated by this rectangle, and all other sets are to be written or drawn inside that set. That is called Venn diagram. Now, this is how Venn diagrams are introduced. Now, the moment we say Venn diagrams, for example, if I declare, sometimes the universal set is declared, right? So, I declare that universal set for me consists of all alphabets. So, X such that X is an alphabet, an alphabet in Roman script. Roman script. Correct? So, in the least method, it will be A, B, C, D, right up to what? Z. This is the set I am talking about. Now, this is my universal set. Now, if I talk about A, that is set of vowels. Set of vowels. Okay. Now, what is set of vowels? That is A, E, I, O, and U. You all know these are the vowels. Others are what? Consonants, right? So, for example, A belongs to capital A, right? But B does not belong to capital A, right? Because A is a vowel and B is not a vowel. So, A is a member of A, B is not a member of A, correct? Now, this is a universal set and this is a set A. So, suppose I want to talk about a set of elements which are not in A. Now, when I say which are not in A, since every element is in universal set, I am talking about all the elements in universal set which are not in A. Remember, when I say set of elements not in A, then where are they? They are in the universal set, right? So, set of elements which are not in A means what? That means these elements are in the universal set, but they are not members of A. That means this implies the elements in the universal set which are not in capital A. Correct? Now, how do I denote this? Very simple. So, if I want to talk about set of elements which are not in A, that means all alphabets which are not vowels. So, what are they? They are consonants. Now, if I want to indicate this by using Venn diagrams, then what will I do? I will use this kind of figure, So, set of all alphabets will be denoted by a rectangle like this. So, this is a rectangle, okay. This is a set of all alphabets, okay. And then, inside that, so this is set of alphabets, all alphabets. That means from A to Z, okay. Now, vowels is a part of it. So, there will be a small section here. This contains what? A, E, I, O, U, correct? So, set of alphabets is this. This is set of vowels. And those elements which are not in this set, they are the outside of this and in this particular rectangle. So, I will indicate it by shading that part. The part which is outside A. So, this is outside A. This is the part which is outside of A. What is this set called? This is also a set. And this set is called complement. Right? So, that defines a new set now. Let us define a new set called complement of a set. Complement of set A denoted by either A dash or A complement. Both means the same thing. So, what is A dash? How do I define A dash? Very simple. A dash is defined as set of all members belonging to the universal set such that by using straight line, such that X does not belong to what? A. So this is A complement, and A complement is this. This is A. This is A, right? And this is A complement. So this is A, right? And this part is called what? A complement. So these are elements in A. These are elements not in A. But not in A means what? They are always in the universal set. Okay. So in this case, for example, if I take A as set of vowels and universal set of alphabets, okay, then A dash will be what? Those alphabets which are not vowels, that means set of consonants. Correct? So these are very simple concepts which can be visualized by using diagrams like this. Okay. So these diagrams are very useful for explaining the concept of set and its complement. Okay. Now, let us deal with certain very important, sets with which mathematics generally deals with. See, mathematics is interested in only one thing, because algebra, as I said in my last lecture, that algebra's basic unit is numbers. So we are first of all getting ourselves introduced to set of numbers. Sets of numbers and their notation. Okay, set of numbers. As we all know, the basic set of numbers is called set of natural numbers. Natural numbers. What are natural numbers? It is, first of all, remember, it is denoted by n, right? N means set of natural numbers, and it indicates elements like 1, 2, 3, 4, 5. This set does not end, and that endlessness is indicated by putting this is dot, 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 dot. Okay, so it is an infinite set. Okay, now the next set is set of whole numbers. Whole numbers. Whole numbers is indicated by W, and generally the set of numbers have got this double line. You may follow it or you may not follow it, but this is how the world convention works, right? This set contains just one extra element and set of natural numbers, and that extra element is 0. So 0, 1, 2, 3, etc., etc. This is called set of whole numbers. Okay. Then we come to negative integers and positive integers put together. That gives you a set of integers, or sometimes it is also called denoted by Z. So what is Z? Z is set of integers. Set of all integers. Set of all integers. What does that mean? That means you can start with minus infinity. You can come at -3, -2, -1, 0, 1, 2, 3. Again, it goes to what? Infinity, right? So this is a kind of set that we talk about, that is called set of integers. Okay. So natural numbers, whole numbers, integers. Natural numbers contain only 1, 2, 3, 4. W contains one extra element 0 apart from 1, 2, 3, 4. And Z contains all negative integers, positive integers, and 0. Okay. These are the basic. Now in this set, all these sets are indicated by by list method, because it was possible. If I write 1, then I know what is the next integer 2. If I write 2, what is the next integer 3. But that kind of facility may not be available in all sets of numbers. For example, the next set of numbers cannot be expressed in this least manner, right? So for example, it is called set of rational number. It is set of rational numbers. Now, set of rational number is denoted by this symbol Q. I will always write a double line here because it's a set of numbers, right? What is this set Q? It's a set of rational numbers. Numbers like half, 1/3, 1/2, like that. That means these numbers have two parts, numerator and denominator. And therefore, we do not know what is the next number in this case. For example, after 1, which is the next rational number, we do not know. If you say half, then if you say after 0, there is a number called half, right? So between 0 and half, there are many rational numbers. Say 1/3 is there in between. Between 0 and 1/3 also there is another. So there is no such thing called next rational. So this method of writing is now exhausted. It is completely outdated. We cannot use it. So I have to use only a rule method here. Right? So that is why we have created a rule method. So what is a rule method? You know? Now, there is a rule method. Now, what is the rule method? So, I'll have to write a rule which is satisfied by every rational number, and that is why it can be called a rational number. So, here I'll write set of all x x's, set of all x's such that. So, x is a variable such that x is always equal to p divided by q. X is always equal to p divided by q, where I must define what is p and what is q, where p belongs to set of integers, and q belongs to set of natural numbers. Remember, natural numbers does not contain 0, so q cannot be equal to 0. Correct? So x is, for example, if I write a number -3, is it a member of set of rational numbers? Absolutely yes. Why? Because -3 can be written as -3 upon 1, which can be written as, -3 upon 1. -3 is negative integer and 1 is a natural number. That satisfies the condition. Okay. If I write a number -11/22, is it a rational number? Numerator is integer and denominator is non-zero natural number. Therefore, it is a rational number, right? So, if the criteria is very clear. Okay. So, that is the next set of numbers. Now, next comes the greatest set of numbers with which we'll be dealing most of the times, because there are numbers which are not rational. Unfortunately, we do not have any separate symbol for representing not rational numbers. So, not rational numbers will be denoted by simply q complement. That means what? That is set of irrational numbers. Irrational numbers. Now, what are irrational numbers? I'm not getting into the details of the definition, but the numbers which are not rational, that means the numbers which cannot be written in this form. For example, a number like √3 or √2 or √11. There are many examples which cannot be written in the form of p upon q. Why and how it is and who can prove it, that is not a part of this lecture. I'll show it some other time. Okay. So these are irrational numbers. So now irrational numbers and rational numbers put together, that means set of rationals union, that is I'll explain it later on. This is q complement. This forms the biggest set of numbers with which we'll be dealing most of the times. That is called set of real numbers. Set of real numbers. So, set of rationals and irrationals together gives you set of real numbers. Set of rational numbers and irrationals together gives you set of real numbers. Of course, this is not the end of the set of numbers, but the next set of numbers is called complex number, which is not a part of our discussion right now. Okay. So now just remember, the smallest set of numbers that we started with was set of natural numbers. Then we increased that set by using what? Adding 0 to it is w. Then we had I, that is set of integers. It can also be denoted by z sometimes. Okay. And then we have a set of rational numbers that is called q, and set of irrational numbers, no separate symbol, qc, and q together we have the biggest set of numbers that is called set of real numbers. Okay. Now once we have defined set, we are now going to define operations on the set. Operations on the sets. So if I have a set A, for example, A, and it contains elements like 1, 2, 3, 4. Very simple example. B is another set which contains elements like 4, 5, 6, 7 and 8. Right? Now, I want to combine all the elements together. So if I make a set like this, 1, 2, 3, 4, 5, 6, 7, 8. Now these elements are here because they are either in A or in B. For example, 1 is in A but not in B. 2 is in A but not in B. 5 is in A but not, 3 is in A but not in B. 4 is in both the sets, right? 5 is in B, not in A. 6. So elements here are here because they are either in this set or in this set, right? So this set is called union and it is denoted by A union B. Correct? So the first operation on the sets is union. Union of sets. Now, union of two sets, capital A and capital B, is defined as set of all elements which are either in A and or in B. Correct? So they are either in A or in B or they may be in the both. So that is why the letter and. So and or in B, right? So logic, if I want to write it in a very short form, then A union B can be written as set of all x's such that x belongs to A and or x belongs to B. Now Venn diagram for this is also very simple. This is universal set, correct? This is A and this is B, right? So what is A union B? A union B is this part, complete, the shaded part, okay? So this is called A union B. So this shaded portion is called A union B, very simple, okay? So for example, in this case, for example, you must have seen, I can give you many examples, like for example, suppose A contains all alphabets, all vowels like A, E, I, O, U. And B contains A, B, C, D, E. Correct? So what will be A union B then? Every element in A union B has to either belong to A or B. If it is in A, it has to be here. All the elements of A has to be in here. A, E, I, O, U. All the elements. Then the elements which may be here are repeated, will not be written repeated times. They will be written only once. So A comes here, but is already eliminated. So B, C, D and E is already included. So we will not be writing it twice. So this is called A union B. Here A belongs to this set because it belongs to both actually, right? And other elements are belonging to this set because they are either members of A or they are members of B. That is the definition of union of sets. Okay. Now let us go to the next operation. I think that can be expressed immediately by using diagrams. So if this is a universal set, this is a universal set, this is a set A and this is another set B. So this is A, this is B. Then what is this set? That set is a set of common elements in A and B, correct? So they are denoted by A ulta U karke, A intersection B, right? It is pronounced as A intersection B. Means what? This means set of all elements which are in both sets A and B. Correct? So they are denoted by this. So this is nothing but A intersection B, right? For example, suppose I have something, I will take the same example which I had written earlier. All vowels A, E, I, O, U, correct? And B contains A, B, C. So what is A intersection B? We have to search for a common element, and that is only one common element, that is called A. So this is A, correct? Sometimes there may not be any common elements. For example, if I write 1, 2, 3, so this is set A, and this is set B called 11, 22, 33, correct? Do they have anything common? No. So in this case, A intersection B are empty. So they are separate. So their diagram would be looking like this. So this is your universal set. A will be here and B will be here. There is no overlapping part. So they are called disjoint sets. They do not have anything in common. They are called disjoint sets. Disjoint sets. They have nothing in common, right? So that is called A union B, A intersection B. Okay. So now this operation can be extended further. You can have A union B, union C, union D, and so on. It goes on. You can have finitely many number of sets which can be added like this, or they can be intersection also. A intersection B intersection C, and so on. This also can be done. Okay. So we have already seen union and intersection. Okay. Now we'll see some another operations. So we have already seen what? Union. We have seen intersection. We have already seen complements. So union diagram is very clear. This is union. A, union B, this is union. Okay. Now intersection diagram is very clear. This intersection this. So this is A intersection B. Complementation, that is also very clear. So this is universal set. This is A and this is A complement. So outside is A complement, So that is shaded part is the A complement. Okay. So these are the three operations we have learned. Now there is another operation called A minus B. A minus B means what? Relative. Remember this word. Relative complement. Relative complement of B with respect to A. Relative complement of B with respect to A looks quite complicated, but it's very simple. The elements which are in A but not in B. Correct? The elements which are complement of B which are in A. That means elements which are not in B but in A. Right? So that means set of elements which are in A but not in B. What will be the diagram representing that? Very simple. This is universal set. This is A. This is set A. This is set B. Okay. Now I am talking about numbers which are in A but not in B. That means all the elements of A which are not in B, that means the common elements have to be dropped off, because those elements are the only elements in A which are also having a membership of B. Correct? So that is called A and intersection B. This is called A minus B. This is called A minus B. So from A, all the elements of A, you remove the elements of B. Whatever is left is called A minus B. It is called relative complement of B with respect to A. I can have a relative complement of A with respect to B, right? So I can have B minus A also. So what is B minus A? This B minus A will be those elements in B which are not in A. So they will be like this. Those elements in B which are not in A. So this set is actually called B minus A, right? So this is A. A minus B means elements which are in A but not in B. B minus A means elements which are in B but not in A, right? So that is how we define the difference between the two sets, okay? So this is another operation, okay? Now, let us call, the next operation is called symmetric difference. Symmetric difference is a combination of both, that is A minus B union B minus A. Now that means this is nothing but, this is a universal set. This is set A, this is set B, this set is A minus B, right? And this set is B minus A. Combination of both will be A minus B union B minus A. This entire operation is denoted by A del B. It is pronounced as del. Okay. So A del B means this. Okay. So now I'll just give you one example where all these operations can be easily understood. Okay. For example, let us take this. Okay. Now for the sake of convenience, we'll take our universal set to be a very small set. Universal set contains 1, 2, 3, 4, 5, 6, 7, 8, 9 and 10. Simple example, right? So there are 10 elements in A. Now there is A. A is what? A contains 2, 4, 6 and 8. Okay. B contains 1, 3, 5, 7. C contains 1, 2, 3, 4, 5, 6. Okay. These are the elements. Okay. And now I want to find out, suppose I want to find out A union B. So what will be A union B? Say straight away write all the elements from A first. So A, 4, 6, 8. And then write the elements of B which are not already included. So 1 was not included, so 1, right? 2 is already included, so 2 cannot, 3 is there, right? Then 5 is there and then 7 is there, right? So this is A union B. What will be A union C? A union C, write all the elements from A, 2, 4, 6, 8. And now all the elements of C which are already not included. For example, 1 was not included, so 1. But 2 is already there, so it's not. 3 was not included. 4 is already there. 5 was not included. So the 6 is already there. So therefore, this is A union C. Correct? If I want to talk about A union B union C, that means I'll write all the elements from A first, 2, 4, 6 and 8. All the elements from A. Then all the elements from B. Since none of them is common, all of them will become 1, 3, 5, 7. Right? Now, in this 1, 2, 3, 4, so this is C is called 1, 2, 3, 4. 1 is there, 2 is there, 3 is there, 4 is there, right? 5, 6, 5 is there, only 6 is not there. So I'll write here 6. Right? So that will be A union B union C. What will be A minus B? Elements which are, before that we'll see, what is what is A intersection B? What is A intersection B? Set of common elements which are in A and B. So there is nothing common. So therefore, this is an empty set, or you may denote it by what? Phi. So empty set. Whereas, what is A intersection C? What is A intersection C? What is common between A and C? So 2 is common, 4 is common, 6 is common. So therefore, it is 2, 4, 6. Okay. Now, what is C intersection B? What is C intersection B? What is common between B and C? Right? 1 is common, 3 is common, and 5 is common. So 1 is common, 3 is common, and 5 is common. That is C intersection B. Okay. What is A intersection B intersection C? But since A intersection B is empty, the whole thing will be empty only because this is empty intersection this. So empty में कुछ नहीं है और इसमें सब कुछ है, लेकिन दोनों मिलके किधर common elements नहीं है. So this will be automatically what? An empty set. So that is empty set. Okay. Now let us see what is A minus B. What is A minus B? So those elements in A which are not in B. So I'll check 2 is in A. Is it in B? No. So it will be there. 4 is in A, but it is not in B. So it has to be there. 6 is in A, but not in B. So it has to be there. 8 is in A, but not in B. So 8 has to be here. But that means A in A minus B here is nothing but the whole of A. Why it is like that? Because they have nothing in common, right? So therefore A minus B is equal to A. So we get a result here. A minus B is equal to A. What does it imply? This implies that A intersection B is what? Empty. अगर दोनों में कोई common है ही नहीं, तो A minus B is nothing but A. Similarly, B minus A will be nothing but B. Correct? Now, the next concept that I want to show is what? The what is it called? Symmetric difference. So what is A? What is A minus B union B minus A? Actually, it is called A del B. A del B. Correct? So A del B will be what? A del B will be those elements in A which are not. So A minus B. So we have already seen A minus B. A minus B is set of all those elements which are not. That means complete A. A minus B is complete A and B minus A is complete B because they have nothing in common. So therefore it is 2, 4, 6, 8, 1, 3, 5 and 7. All the elements of A and all the elements of B are there. Why? Because they don't have anything common. But what is A minus C union C minus A? Okay. So elements of A which are not in C. So 2, 4, 6, 8. So there is an element called 4 and 6 which are common. So they are not to be included. So 2 and 8 are the only elements in A minus C. Correct? 2 is in A, not in C. Sorry, 2 is also there. Oh, sorry. Let us check. 2 is in A, it is also in A, so it should not be included. 4 is in A and 4 is not in, 4 is also in this. 6 is in A, 6 is in A. 8, so A minus C, A minus C union C minus A. So this means it contains, A minus C contains only one element and that is 8. Okay. Now C minus A. All the elements in C which are not, this was what? 1, no, 2, 4. So now, in C, elements in C which are not in A. So that means 1. Okay. Now, 2 is in both, so not included. 3 is in A, but not in B, in A. So 3, 4 is already there. 5 is not there. Okay. And 6 and 8 is there. Correct. So this will give you A minus C union C minus A. Correct. So this is the example of all the operations that we have learned. Okay. Now this is a theory, but no mathematics can be completed unless you use it for practical solving problems. So I invite everybody to take any NCERT book and take the exercises from that NCERT book and solve it. And if you cannot solve, please refer to those problems and send them to me on the email pmzakatdar@gmail.com. Apart from that, for those of you who have paid attention to this particular lecture, who have followed this particular lecture, at the end of every lecture, I am going to create a very, very challenging problem, right? And I want those students who have the answer, please post their answers to my email and you will be getting recognition for that. Your names will be published in the next program, okay? So, the challenging problem of this topic is, remember, it's not going to be very easy topic. It is slightly challenging, but not very difficult to solve also. So the problem, see, I'm ending my lecture with a very challenging problem. I have not solved a problem of this type in my lectures, but still, those students who are curious and very, very creative will be challenged by the kind of problem that I'm asking you. If N is a suffix, denotes all the natural numbers from 1 to 200 which are divisible by n. For example, S3 indicates all natural numbers from 1 to 200 divisible by 3, such as 3, 6, 9, and the last number which is divisible by 3 before 200 is 198. So that is the meaning of Sn. Now, the problem is to find out S3 union S5 union S7 minus S3 intersection S5 intersection S7, right? So this is a problem and the solution can be posted on my email. I'll repeat my email. It is pm@gmail.com. Thank you very much. Okay.